Today we're going to move on to 9.2, which is stem and leaf plots, with just a little sprinkle of 9.1 in there. And here is the sprinkle of 9.1. You're going to see this question on your homework tonight. It says the finishing times of people in a 100-meter freestyle swimming event were collected. The quartiles for the data are shown. So I wrote this down here. So I have quartile 1 is 62.05, quartile 2 is 69.16, and quartile 3 is 71.43. Now remember, when we take these three quartiles, it breaks up this data into 4 equal groups. And each group represents 25% of the data. Now, in this question, there are 40 people. So that means these 40 people are evenly distributed amongst each one of these 4 sections. So that leaves this section represents 10 people, and this section represents 10 people, and so on and so forth. Okay? Now, you're going to see on the homework, you're going to see there's more to this question, but that's just a little hint to get you started. Now on to 9.2. The first thing I want to talk about is mode. And mode is the value or values that appear most in a data set. Now this is something you should have done in the past, but just a quick review. So here we go. I have a few examples here. For example number 1, I have these numbers, 387, 1294. Now, as you probably recognize, I didn't say any particular number more than once. So there are no numbers that appear more than any other. So therefore, there is no mode here. Okay. The next one here, we have 5, 7, 12, 7, 8, 5, 7, 9. Now you might have recognized that I've said a few 7s. So I have a 7, and a 7. Now there's another number that I said more than once, and that is 5. So I have 1, 5, and 2, 5. So the number that appeared more than any other number is 7. So the mode here is going to be 7. So far we've seen that we can have no mode, we can have one mode, and let's check out example number 3. We have 4, 8, 12, 8, 7, 6, 4, 10. So I said 8 a couple times, and I also said 4 a couple times. So I said both of those numbers 4 times. So those two numbers appear more than any other number in the data set. So therefore, the mode here is going to be 4 and 8. And the last one here, I have 3, 3, 4, 4. Now there are no numbers here that appear more than any other number. So therefore, there is no mode. Now, let's just say I added another number. Let's say I added another 3. Well, now all of a sudden, there is a mode. And the mode would be 3, because the 3 appears more than any other number. So on to the main part of 9.2, and that is creating stem and leaf plots. We're just going to make one today to start out, and then answer a few questions about it. Now, all these numbers here, those 25 numbers, let's just pretend that in class I had 25 students do a broad jump, which is when you just stand with your feet together and you jump without running as far as you can. So each one of these numbers represents a certain amount of inches. So one student jumped 27 inches, another jumped 29, and so on and so forth. So what we're going to do, if I asked you to go ahead and tell me what the greatest number there, or what the least number was, or which what's the mode, what's the most that somebody had, it's hard to tell from that. You could figure it out, but it would probably take you a while to do it. So what we're going to do is we're going to take this data and we're going to put it into something called a stem and leaf plot. So the first thing I want to do is I want to put these numbers in order from least to greatest. So let's do that. Now they're in order. Now, full disclosure, as I was doing this, you'll notice that this 38 is circled because when I originally wrote the numbers, I left the 38 out. So it's really important that when you guys do this, for some reason can be a tough thing, that it's very easy when you have a bunch of numbers to leave a number out. So when you're done writing the numbers out, make sure you count your numbers, count the original numbers, check it and double check it just to make sure you have it right. So to make our stem and leaf plot, it looks like this. It looks like a T-chart. So we have stem, and over here we have leaf. Now the first thing we're going to do is we're going to create the stem. And to do that, what we're going to do is we're going to look at the data up here. And we're going to look at the number in the tens place. So I have numbers that are in the twos. The smallest number that I have for the tens place is a 2. And the greatest number that I have is an 8. So what I'm going to do is I'm going to write all the tens digits from 2 to 8. Okay, so I'm going to write 2, 3, 4, 5, 6, 7, 8. So what this does, all these numbers represent, this number is going to represent values from the data set that are in the 20s, from the 30s, and so on and so forth. Now notice here that there are no numbers that are in the 40s, but I'm still going to put that 4 there to represent numbers in the 40s. And what we're going to recognize that when we see the stem and leaf plot completed, that in and of itself gives us some information. We're able to tell right off the bat there are no numbers that are in the 40s. Okay, the leaves. So I'm going to start making them. I'm not going to tell you exactly how I made them to start off, but see if you could figure it out. So for the stem of 2, I'm going to go ahead and for the leaves, I'm going to write 4, 7, 9, 9. Now see if you can figure out how I got them. For the 3s, I'm going to write 2, 3, 8, 9. Now, there are no numbers in the 40s, so there are no leaves for the 40s. But I'm not going to put a 0 there because that would represent 40. Let's move on to the 5s. So I'm going to put 1, 1, 6, and 9. So I'm going to stop right there and ask you, see if you figured it out. So this number right here, this 4, doesn't represent 4. It actually represents 24 because we use this stem to partner up with all these numbers. So this number represents 24, this represents 27, 29, and 29. So on and so forth. This represents 32, 33, 38, 39. All right, let's move on to the 6s. So for 6s, I'm going to have 0, 0, 1, 1, 1, 3, 4, and 7. And then for the 7s, I'm going to have 0, 1, 2, 2. So 0, 1, 2, 2. And then for the 8, I'm going to have just a 3. So now we have a stem and leaf plot, and it's a little bit easier for us to go ahead and determine some information. If I asked you what's the smallest number, well, it's kind of easy to see. Well, this number is 24. What's the biggest number? 83. I don't have to search through here. Now, the last thing we have to do here is we have to go ahead and tell people how to read this chart. So what we're going to do is we're going to make a key. And the key looks like this. I always like to choose the very first number. So the very first number here is 24. So I'm going to write 2/4 equals 24. So as you read this number right here, 2/4, that represents 24. In theory, you could choose any number from this data set, but I like to choose the very first one. So we've taken care of A, we've made our stem and leaf plot. Let's go ahead and answer the other questions. For B, what's the range of the data? If you remember from the other day, the range represents the greatest value minus the smallest value. So in this case, the greatest value is going to be 83, and we're going to subtract the smallest value, which is 24, and that's going to give us a range of 59. All right, next up, what's the mode? Again, the mode is the number that appears the most. So we can look through here, and we have 24, 27, 29, and if you keep looking here, so these numbers we have 2 of these numbers. So this is 2 29s. We have 2 of these numbers, which is 2 51s. We have 2 60s. And look here, we have 3 61s. So there's no other number that appears more than any others other than 61. So 61 is going to be the mode. Okay? Now, what's the median? Remember, the median is the number in the middle. Now, I have 25 numbers here. Okay? So, if that's the case, I know that the 13th number is going to be the one in the middle. And I just do that because I just say to myself, well, if there's 25 numbers, I take one away. That equals 24. And I divide that 24 by 2, and that equals 12. So that means there's got to be 12 numbers on one side, the middle number, and then 12 numbers on the other side. So that means the 13th number, if I just take this 12 and add that 1 back, the 13th number is the one in the middle. Of course, you can just count it, but that's how I always kind of figure it out. So the 13th number is the one in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this number here, 60, is the one that's in the middle. So the median is 60. Q2. I'm sorry, let's find Q1. The median is actually Q2. Q1 is the median of the lower half. So this right here is the median. So Q1 represents the median of all these numbers. So there's 12 numbers here. So to find the one in the middle, I just cut 12 in half, that's 6. But remember, there's going to be 2 numbers in the middle because 12 is an even number. So that means the 6th and the 7th number are the 2 in the middle. So 1, 2, 3, 4, 5, 6, and 7. So these 2 are the ones in the middle. So I have 33 and 38. So I have 33 plus 38. And then we divide that by 2 to find, because remember, when there's 2 numbers in the middle, we add those 2 numbers together and then divide by 2. So 33 plus 38, that's going to give us a 1 there. That's going to be 71 over 2, which is 71 divided by 2, which equals 35. So Q2 equals 30, nope, Q1, I apologize, equals 35. Now Q3 is going to be the median of the upper half. So starting with this 60 all the way to 83. Again, there should be 12 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 6th and the 7th number are going to be the ones in the middle. So 1, 2, 3, 4, 5, 6, 7. So these 2 are in the middle. So this is 64 and 67. So we just do 64 plus 67, and we divide that by 2. All right? So that gives us 131 over 2. So 131 divided by 2 is going to be 65.5. So Q3 will be 65.5. All right. And the last thing, guys, so that finishes up this problem. The last thing that you guys might run across, let's just say, for example, there was somebody who jumped, let's say, 104 inches. So let's say we have 104 inches. All right. So we'd have to go ahead and add on to this. So there's nobody in the 90s, but we'd still put a 9 for the 90s. And then the stem for 104 would be 10. Okay? And then, of course, the leaf for that would be 4. So you might run across some of them that have triple digits, and that's how you would handle it.